All right, we're back. We're back with more DiSco-MIMO. Today is sort of a big day for streaming, but it's also, we're getting towards the end of code if you're watching the series on YouTube. So let's put the recap out, but let's also get right onto it because there's not much time left to write the paper. I think where we left off last time is we sort of reworked the config a lot, and that's pretty much done. So now we have OmegaConf and Hydra. We just need to add typing, okay, with Pyrite. And I think that's it. We're very, very close to done. In fact, that's probably one of the last clean code things I want to do. Then we can finally revisit data generation, but that's probably another YouTube episode. And then we can write the paper, okay? So let's get right down to it. Let's see where the code is. I also trained the model in the downtime, okay? So let's see, what do we have here? So we have, I did do a few more tweaks, very minor though, nothing to be scared. So then I can do, let me just commit everything. So git add src mimo train, packaging and training tweaks. Okay. And where are we with training? So we trained the model, NCSN v2. I also changed the activation to ALU, not RALU, so it matches the paper even more exactly. OmegaConf is very clean. We only have one source of truth now for these numbers. Looking very, very good, right? Because I was able to do, for example, in downtime, when I trained the model, I just did this, MIMO train, models minus paper, and I even matched the number of training steps and the noise level, the max, which I can just override from the console. It's 27.7 now. So this looks very, very good. So let's go back to our pre-commit config. So now what is typing, right? We've actually never done this before. Now you notice in Python, I like to write my Python functions to have these semicolon types and arrows, like this one, right? So the forward function for the UNet 2D model takes a sample, which is a tensor, a time step, which is a union between blah, 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 and it returns a tensor. That's what this arrow means. Now, if you know a bit of Python, you may wonder what the heck is this guy doing, because this doesn't matter in Python, okay? So this is purely informative right now. I can change the max noise level here to a string, and Python is not going to complain about this if I actually pass in a float. But typing enforces these before any code runs. Okay, so that's the goal. We need to make these useful because now they're sort of like eye candy. You can pretty much make them mandatory if you enforce these typing checks, right? So this is called Python typing. Support for type hints, which is a relatively new feature in 3.5, I guess, a few years ago, many years ago, but not in Python 2. And this is basically it. Modern Python code should look like this. All the function definitions should be typed. Okay, so you should tell the code what the inputs should be and what the expected output of a function should be. The thing is, this is not enforced, right? So for that, we're gonna have to use a package called based Pyrite, which is sort of a fork off of Pyrite. And all we need to do is we need to integrate this in our pre-commit, and it's gonna yell, oh, look, you're not passing in the right thing before any code runs, etc., etc. So then we just need to find a based pyrite pre-commit hook. Okay, so first we need to add based pyrite to our dev dependencies with UV, okay? So we do UV add based, or to group dev based pyrite. And there we go, that's it. UV takes care of everything, resolving the dependencies and everything. And let's see how the pre-commit looks like, because again, the PyProject. Now, again, what I always like to do is I just like to freeze this to a version. I also move some dependencies to core. I move Hydra to core dependencies and Matplotlib and Omega Conf. This is fine. Oh, we can actually cut Hydra from here now. Sorry. Okay, so we can lock again now. Okay. So we can say, let's see, we can add this PyProject UV lock, add based pyrite dev dependency. And now we just have to define it as a hook because it doesn't run as a pre-commit hook. Now, once I do this, I'm probably going to see a ton of errors that we'll have to fix, but it's fine. That's the whole point, because it's supposed to identify inconsistencies. If I pass the wrong thing, for example, if I accidentally pass a float, it'll just yell before any code runs. And that's the point. Okay, so we have to go back to see. So I just need this pre-commit mirror, I think. Yes. And that's it. All I have to do is I have to go to pre-commit config, repos, and I add a new repo, which is the based. Oh, I just actually indented one more. Okay, there we go. It's not 113. It should be, what is the latest version? 138.3. That's the one we installed, right? 138.3. And I think that's it. Now, if I run this, get ready because it's gonna ruin all the code, possibly. Let's see. UV, run, pre-commit, run all. It's probably gonna install the hook. There we go. So it, let's see, what does it want here? So repo rev. Let me see. How do I use this? Maybe this version is not up to date. Yeah, it's probably a bit behind. So what is the latest tag? Oh no, it is 138.3. So I can't check this help aspect, not mentioned infos to get UV run pre-commit install UV run pre-commit run all. No, why can't I get this then? It's because it's not tagged 138.3. Based pyrite pre-commit hook. I know they say they don't recommend pre-commit, but that's fine. I don't want the prec mirror. Oh, wait a second. This is, I know what's happening here. So I'm looking at the wrong repo. Did they deprecate this? Damn it, I think they did. So it's only 113.0 then. Let's try this one. Yeah, okay, so we need to use an older version. Okay, so it's installing base pyrite and it's gonna yell now. Okay, this may take a few minutes. It may actually take a few minutes. Oh, there we go. Okay, so now it's finally running. Based pyrite. Now, there we go. So we have a ton of type errors. Wow, we actually have a lot of type errors that we have to fix. Type of item is unknown. We actually have a lot of errors now coming. Aha. The problem is that there is some incompatibility with there is some tension between incompatible dependency groups. Woo, which is pretty bad. So I guess we'll have to skip the imports. So some of the imports could not be resolved, right? Because let's see. So what do I have sync here? UV pip list, grep tqdm. No, I can't. Yeah, so I have tqdm here. Actually, let me just move tqdm to global depths then. Okay, so we only have Siona. I also created a new dependency group called paper for some plots. But there is a conflict between the torch and Siona group. UV lock. Okay, so let's add the hook. PyProject UV lock pre-commit config. Add pre-commit hook for based pyrite. Now we have a lot of these errors to work through, but it's not as bad as it seems. UV run, pre-commit run also. We're just gonna have to fix them in order now. There's no other way around this, generally speaking. Let me put myself here. Okay, so let's start with MIMO train. So for example, all these errors, they look like, what does it say here? Basically every line is an error. So line 5, okay? Import torch could not be resolved. Okay, the imports we can ignore. Type of atom, 625 is unknown. So we can ignore the missing imports. So type, ignore, report missing imports. And we can just run pre-commit on source MIMO. Let's see, file, source MIMO train. Also, just the imports fix everything here in train. So if I let this go, I guess it can't proceed further. Yeah, because I guess most of these errors are what, 139? Oh yeah, it just doesn't know what torch is. (138) type of save verbose is partially unknown. Why does it say unknown int? Because this should be an int, right? Oh, I see, because I also resolve to object. I actually wonder if I need to do this now. Probably not. What if I just take CFG and I just save CFG omega conf to container? Do I fix more errors here? Not really. So for example, line 79, type of P is unknown. This is because it can't see in the torch import. So it has nothing to do with this. I should change this back. So if I can't ignore the missing imports because it defeats the whole purpose. All right, so let me look up some documentations then. So pyrite with UV dependency groups. Well, this is gonna be a problem because I lose all the benefits of I wonder if I force this here inside torch. So I say UV sync. No, it still can't see. So pyrite with conflicting UV dependency groups. Aha, this is the problem. Ensure your pyrite config or PyProject uses the VMV path that UV is syncing into. So it sees the correct pre-commit hook. The issue creates an isolated environment for the hook. Yes, this is the problem because which may not have access to your project specific. Yes, this is it. UV by design test result during lock sync, which fails. This is the one. Sync pre-commit with UV. Aha. This is the one. Yes. Okay, this is what I need. Sync pre-commit with UV. Aha, okay, I know what's happening here. So if your pre-commit looks like this, but your UV log says using, then the hook will change YAML. If it looks like this, to synchronize the additional dependencies, then UV upgrade will hook. So we need to use this repo. Pre-commit config. Because I think this is really, really important. Hooks ID sync. So what is the current release of this? 110. V110. UV, let's see. What revision does it want? 110? Okay, it's installing this one. It's gotta be this. Sync pre-commit with UV. This is good to write in the paper too. This is pretty advanced actually. Let's see if this is gonna work. Based pyrite. Still doesn't work. Because I can't see the imports, right? That's the big problem. Yep, import could not be resolved. So what do I need to do? UV, whoops, sorry. UV sync again? I don't think so. Group torch, group dev. UV run pre-commit run all. We're very close, but what is this? Mapping the pyrite hook to the appropriate UV dependency. This ensures the isolated has the correct non-conflicting dependencies installed. You can run pyrite using UV run. Pyrite is installed. Use a local hook. Actually, maybe we need this then. So pass file name, structure dependencies for compatibility. Nah, we don't have, we can't do this. Map specific hooks with UV groups. This is what I need. So how do I add a group then? Oh, here it is. Ah, okay. So I also need to I need to configure this in my Pi project. Additional dependencies, UV params. Uh-huh. Oh, yeah. Okay, so this will be Pi package name based pyrite for us. Right, so it'll be like tool commit pyrite has, so it'll be based pyrite. So Pi package name will be based pyrite. And additional dependencies UV params. It's gonna run under group torch. UV run pre-commit run all. Nope. So the Pi package name is still based pyrite. Yeah, this is the one. Tool sync pre-commit. So do I need to install this too? Look for all the repo keys in your pre-commit. By default, the tool will try a simple repository. And the mapping in your Pi project configuration. Here's the anatomy UV repo name. So what is based pyrite name then? It's just based pyrite. So pyrite Python is something else? not really. Here's the anatomy of entries in your Py project. Repo name, the name of the repository, the part after the last. For repository and pre-commit does not have a corresponding entry in Py project. So, it's the based. Pre-commit mirror? What the heck is this? Okay, so I do need to change this. This should be called based pyrite pre-commit mirror. Let's see, and I don't need this. So will this make it CTorch now? Oh, very good. So based pyrite reference but not found in lock. So it's just based pyrite then? Sync repos with UV passed. Yeah, so I need group torch. This is exactly what I need here. I need additional dependencies UV params for based pyrite. So how do I run this now then? Should I switch to this prec thing? Prec mirror, see documentation. Let me see what Gemini says. I think there's an easier way to do this, right? I'm using UV for virtual environment management. I would like to set up a local pre-commit hook that uses my local virtual environment. Yeah, that's the problem. Pre-commit prefers to manage its own isolated environments. Yes, this is what we want. So to make pre-commit hook user local, you set the language to system. Okay. If you're already in using UV run in the entry field safety first, this is a traditional way. If you're trying to use standard tools, you don't actually need to use your local environment. No. The problem is I'm trying to use based Pyrite and it needs access to my local dependencies, to my project dependencies. So I can just do UV run based Pyrite. Okay, this is, yeah, okay, so it's only 33 errors. All right, okay, I get it now. It's only 33 errors. Yeah, type of missing is any, report any. Okay, so these are actually pretty easy errors to deal with. Okay, so yeah, let's use a local hook then, right? Yeah, I think this is better because we just need an entry. Pyrite usually handles the whole project at once. Yes. Okay, this is better then. So we have the dependency already, and we're just gonna set up a local repo hook with base Pyrite. UV run ensures okay. So entry will be pass file names false, I guess. This is fine. And now if I run UV run pre-commit run all, okay, there we go. Only 33 errors. This is exactly what we wanted. So now we just enter with UV run based Pyrite. So actually there's a smart way now, because what if okay, here's a more advanced way. Perfect. Now let's go with option 1. Actually, I want to do something even better now. Here's the other issue. I have 2 conflicting dependency groups, and I would like to UV run group based Pyrite twice with each group by also exactly specifying which files should be checked in each group. I'm okay with hard coding this because we want to check the CDL model under this is specific. Yeah, thanks. Since you want to hardcode, you will create 2 separate entries, right? So we need 2 hooks now. Okay, so we're gonna call this based Pyrite for torch and UV run group torch and dev my filters is there a way to specify the files for the second group and everything else for the first, one by one? This is what I want, because I know it's only the CDL thing, right? Here we go. So this is what I need. So what's gonna happen, so we're gonna run 2 hooks now with 2 different names. Okay, so they'll be based Pyrite torch, torch. So it'll run torch and dev. Okay. Language system, pass files and false, exclude specific files. So then we're going to exclude src, MIMO, cdl.py. That's it. We know this is the only file we need to exclude. And then the other one will be base pyrite Siona, because we have a conflict here with Siona. And I'm gonna run UV group Siona and the dev. UV run group Siona dev base pyrite. And the file will be... I see, this is exclude. It's exactly the same thing then. So it's src MIMO CDL, except it's included, not excluded now. Now if I run UV run pre-commit run all, I should see two hooks. Base pyrite torch is running first. Group Siona and torch enabled by default. Oh, why can't I run the Siona hook? Oh, did I mess up the default? Oh, whoops. Sorry. I need to remove torch from... actually, I broke the repo. Okay, so let's do it this way then. Let's just leave the dev, because I don't need to specify it then. This is even cleaner. Okay, so I can lock again. And now I can run. Okay, so now it's running the Siona on a single file. It should. Come on, come on, come on. Takes a while because it has to create the environment, I guess, the first time, which is fine. I would hope this gets reused. Why does the CDL take so long? Okay, there we go. But why does Siona check the train? Oh, okay, this is not good. Wait, almost there. Not quite, right? So if I run... so what's happening here? So if I run all again... I'm seeing the same errors. Argument is blah blah blah. So what if I run manual then? UV run group Siona based pyrite. Well, it's gonna run on all files for sure. Okay, so I get 29 errors, but then if I run group torch... Okay, I think I'm making a mistake when I run pre-commit though. Pre-commit run. Uh-huh. UV lock. Commit. Add local based pyrite hooks. Well, interestingly, this will actually... Aha, okay. So I know what's happening here. Okay, so no files to check for Siona. Why no files to check for Siona? src MIMO CDL PY. Oh, because nothing was changed, right? Come on, why am I getting so many? The thing is, why do I... Getting a ton of errors for CDL. Which I definitely should not. Return type is any. So why this doesn't seem to work then? Something is a bit off here. Pass file names false, which is necessary for quick commit, only use the files and exclude keys at the hic. Once base player usually scans include to make this work perfectly. In group B's entry, you might want to pass the files explicitly. This is what I need then, so it doesn't scan the whole project. So UV in group A, ensure your PyWrite config or PyProject has the group. Yes, I need to see that there's a missing complement. You need to align your PyProject where base PyWrite looks for settings. Okay. This creates the default behavior for group A. So then I go here. Yeah. Okay, I gotta nuke this sync tool though, because this was not a good choice, I think. Yeah, this is a dud here. Yeah, okay. This is a bit more complicated than I thought. So, for base PyWrite, by default, we just need to exclude src mimocdl.py, okay? And type checking mode standard, blah, 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 VMV path, VMV. Let's see if this has any effect. Now we tweak the hooks. Group B, we explicitly pass the file names. This regist should max the exclude list. So UV run group B base PyWrite. Yeah, I'm okay with this. So I can say UV run group, it's src mimocdl.py. So actually, can I run this? Let's see, group Siona. Not really, right? Oh yeah, I can. Okay, so there's no errors in CDL. So I think what's happening is there's a trick here, because when I run, I think the all is tricking me. UV run pre-commit. I think it's the all that's tricking me. This should pass now because I don't have anything staged, right? Okay, this can be perfected, but I think I saw the 30 errors are the real ones, so that's interesting. Yeah, it sees the exclude list. Ignore the configs include. Won't trigger group be hooked unless one of these studies. If you have a lot of files, maintaining two identical lists can be annoying. You could technically use a second config file. No, I don't want two config files. Oh, it's taking so long because it has to switch the environment. Oh, come on. Is it really going to take like... I guess this is why people complain about these things. Yeah, so really the real evil is the fact, man, so all the paper we're going to write is going to have to say a lot about conflicting dependency groups, because this is brutal for... you have to run checks twice. I'm not sure what's happening though here. Is it like stuck? Ah, I guess it is. So what, I can't sync now to group torch? Ah, there's another complication now. I know what's happening. This is good enough, but I have one more use case now. I want to trigger both pre-commit hooks myself during development, ideally on all files. If I just run uv run pre-commit or uv run pre-commit run all, this doesn't seem good because deleting uv run assumes a specific dependency group. How would I even solve this for local development when I want to check both groups? Yeah, something is not good here. I think I also busted up the... may or may not have corrupted the environment, but that's fine. The point of UV is to... we can always delete the environment. Okay, so I can do UV sync group torch again. Well, let's see what Gemini is saying. Yeah, this is the problem. If you run UV run pre-commit, UV creates an environment and then pre-commit runs inside that. The trick is to not use UV run, but let the hooks. The cleanest way is to have UV installed as a tool. Ah, this is what I need to do. Yes, so I need to UV tool install pre-commit. So then I can run pre-commit. Pre-commit starts up, it hits hook 1. It executes UV run. Because UV is extremely fast, if you must run, if you absolutely want to be a dev dependency in your Pi project, you can still run, but you make sure the outer environment doesn't blah, blah, blah. I can't do both. Since you'll be running a shortcut to do check types. using UV's dynamic script runner. If you're using a recent version of UV, then you just type UV run, handles the whole orchestration for you. The problem is my two dependency groups are conflicting, so the joint approach doesn't work, right? Yeah, so they're truly conflicting. So I need to do UV tool install. Yeah, so UV solves this too. So I just do UV tool install pre-commit, which is a completely different beast. And now I can run pre-commit. Oh, I just ran pre-commit. I see, and it dispatches the hooks. Why does it take so long though? Yeah, so if you don't want, you can define a composite script. UV run type check all. UV run is smart. When it sees group, it looks as you blah 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 blah. Quick warning on these. Your ID might get confused because you just pick one interpreter. Nah, red squiggles are fine. Okay, okay, the tool approach works, but now the hook invocation takes very long. I'm on Windows with this hook. So I have this hook. Is it possible it's checking all my files or something? On Windows-based Pyrite scanning a large dependency like Torch. So maybe it really is warming up for Torch. I've never seen it take this long though. To speed this up, exactly which directories on the entry command? Update your hook like this. But I also want to exclude the CDL-PY file from scanning in this group, as well as triggering. Oh yeah, so I did, okay, yeah, so we did this, right? Update your pre-config, keep the exclude here as well. So I can just do this then. Yeah, this is all nice and good. The problem is my Pi project, where does it have? Let's see. Yeah, exclude src MIMO CDL. I guess I can also do PyCache VNV. Nah, these should be easy though. I don't care about these. Maybe I need to, I'm not sure what's happening with these guys here. So if I run pre-commit on all now, okay, this still seems to freeze for me now. Why? All right, so we kind of have it nailed. It's pretty basic. It should really exclude it though, like tool base pyrite, blah, blah, blah. So it will exclude it. It also is going to exclude it from triggering. It'll only scan this one with Siona, group torch. This looks okay. The setup is pretty basic, except something is dragging it, so it takes too long. Since you mentioned it's taking a long time, a significant faster pyrite configure tool-based pyrite. Without this, searching for interpreters on VMV, set VMV. This prevents you from accidentally trying to index your global Python library. I guess. Give me the section. Searching for environment delay. Could it be this? I don't think so. VNV path. Is there any way to make base pyrite verbose while running the hook to see why it's so slow? Like, what is it doing? The fire hose verbose. If you want to see the live output, yes, I want to see the live output. So I'm gonna do -v then. Okay. -v. Pre-commit, run all. What happened here? It failed. Interesting. VMV path. Let me take these out then. Wait, so can I just run? Oh shit, sorry. Can I just run this hook then? The V flag doesn't work for based pyrite. It's VNV path, not verbosity. Yeah, this is AI doing a bad job. You're right. And base pyrite is for VNV path. Is it verbose then? Oh no, wait, it didn't pass. Nah, it's probably not verbose, right? I guess it could be, but I still don't know what it's doing. Yeah, this is not good. The stats show that it's taking forever to resolve imports. Oh, remember to run with its own flag? Okay, sure. Let's see. Maybe this. Nah, but it still hides it from me. I can't see any live output with verbose for the pre-commit hook and V for pre-commit. This is not good. This is a classic pre-commit capture standard out. To index store, you're just staring at a blinking cursor. The bypass for real-time debugging. To see the live, you should run the entry command. Okay, sure, we can do this then. This is easier. So I can just run myself. UV run group torch based pyrite verbose. Okay, here we go. Okay, finally. Okay. Wow, okay, I'm seeing a lot of stuff here. Could not import. Long operation. Damn, so it really is checking all my stuff. Yeah, so this works, but it takes a crap ass time then. Okay, so I found the outputs. Okay, this works. It's taking a ton of time to index my local libraries, it seems. Are these results cached? Accelerate. The heavy is being depanelized, taking 30 seconds. Yeah. Yes, caches, but the major cat base processors bound information in local cache directory. Subsequent runs should be faster after reparse. Pre-commit can sometimes interfere. It's trying to infer types because it can't find high quality type stubs. To stop this deep crawl. Okay, so we have to do this. I mean, we're not gonna. If there isn't a PRI stop file for either, just treat the imports as unknown. Spend 30 seconds to read library internal logic. Is it actually catching? Interesting. I mean, we can't let this run, but yeah, we should not do this. Okay, so, right, because we only want the app logic. So hang on, it's getting there. So then we want to tell it, use library code for types false. Let's see how fast is this one. Okay, sure, it's still doing a bunch of crap. Why, come on. Nah, but I'm still getting I feel like this is a This is definitely an accelerate problem. You told if there isn't a POS stuff, if that folder is empty or stays after run, the cache isn't persisting. So local app database, Pyrite, Python analysis. Let's see. So let me paste this into Windows Explorer. No, there is no folder. Never mind. So that was a scam. Since you're using UV run, UV is very efficient. Base price is still bottleneck. If you use the ignore setting, well, your hook time should drop from minutes to seconds. It doesn't seem to work though. Even with, I'm still seeing it deep check libraries. To truly, you need a more rigorous execution environment. The hard ignore, what it's still analyzing. Looks for a stub. Library code, if it won't look inside the trap, it still feels obligated to parse the init and the target file. Check your PyProject for a setting called extra paths. Make sure your VMV is strictly defined, not an include or extra paths. The cache corrupted. If you've been toggling, cache might be in a half-baked state. I mean, yeah, we're searching. It's searching for the entire accelerate. Okay, here's what we'll do. Why don't we do it this way? Leave this, because I like these hooks. Why don't we ditch support for the UNet? Yeah, because we're not gonna have time to write about that anyways. So we can just kiss goodbye to diffusers for now. Well, let me commit this actually. Yeah, not the greatest, but so git add pre-commit config, git add PyProject. Can I lock this? Git status. It's locked. Git commit -m. Local hooks, no verify, because we can skip all that. And yeah, let me get rid of diffusers then. All right, so UV lock. There we go. This should wipe a bunch of stuff. So it wipes accelerate, diffusers, etc. UV sync group torch. Yeah. Okay, so we don't need all that stuff, and we should also get rid of the model for now, which is fine because it is modular. Okay, so we can get rid of the diffusers case, and I think that's it actually. Oh, interesting, this is bugged now. There we go. We don't even need the UNet config. Yeah, I think this is it actually, right? Okay, so now I can run pre-commit, run all. Oh, sorry, there is something, I left something unknown here, line 71. Oh yeah, get diffusers model is no longer accurate. Okay. And sampling, I don't need sampling, right? Because I just see get model here. Yep, very nice. So now I can run, what was I running before then? Oh, this one. I can run explicitly this one with verbosity on. Oh, no, actually not. It's even more detailed than this. Here we go. I was running it like this. Okay, so blah, 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 blah. It's searching for some stuff. Simpi, okay. Okay, so it's checking some typing, some PIL stuff. Should be a lot faster though. Come on. Long operation, analyzing. Oh, it's analyzing itself now. Network X. No, it's analyzing Network X. I still feel like something is wrong here. Like, do we have some... Okay, so what do we do here then? I still don't know if it's a... So what are my hooks here? Base right pre-commit mirror 113. Base pyrite pre-commit mirror 113. So I don't even do, because I don't have groups. Okay, so we do need all this stuff actually. Maybe this type checking mode. Ah, damn it, hang on. Let me try this one then. So it does need the type checking mode. It's worse than I thought. Deprecate typing aliases. Does seem a bit faster now, but still it's searching across many things. Okay, all right, now it's finally done. Okay, so this is not that bad. Okay, so I do need type checking mode standard, and I do need to specify all these things. Now it's finally looking at my source code, which also takes a long time. But you would hope that it excludes what I told it to exclude. All right, I'm gonna take a quick break. We'll leave this running because we don't know what else to do. So we'll be right back. Thanks for sticking around. Oh, it's still fiddling around. Damn, it's searching everything. All right, let's take a quick break. I'll be right back. Thanks. All right, we're back and this thing is still not done scanning. This is not gonna work out. I think I'm just gonna give it up for now. Yeah. Like, why is it searching for my whole ENV? Can I just... Wait, maybe I need to exclude it like Gemini said. Let me try one more thing, I guess. Yeah, the nuclear option for speed. Like, I'm just gonna do this then. Ignore. Yes. Can I see if base pyrite is accidentally treating my virtual environment? This is what I want. The most common the reason ignores your screw. We need to look at her roots. Yeah, okay, so everything, like, this is a disaster because I see, I mean, I can't even see anything here, but it definitely looks like it's treating everything as if the paths are mixed up, you can force. This tells the analyzer exactly where your border is. Yeah, I'm just gonna ignore everything then. I'm gonna do the nuclear option for speed. Let's see if this works. If this doesn't work, something is bad. And then what does it want? Let me just do this. Include SRC, right? This makes sense to me, yes. Okay. Again. So UV run group torch base pyrite verbose. Ah, okay. Okay. Almost. Okay, so this was it. Jesus Christ. So now I can run pre-commit, run all files. I can. So now, oh no, Siona is doing the same. Oh no, Siona passed. Okay. The nuclear option worked. Damn it. Yeah, this is... Can I just ignore VNV then? Like, why would I not do this? Yeah, I can. Okay, so I just have to fix 9 errors. But my question is now... Okay, so I'm not seeing CDL here, right? Let's make an obvious error. So here's an example of a typing error that you can do. Like an obvious typing error, I can do like x int equals 4. This is obviously a typing error, so this should show up when I run pre-commit, run all files. It shows up on a different... Oh, there we go. So it does show up here. Which is what? Train line 85. Float or string is... No. Train line 85. Type is not assignable to int. Okay, so everything works. Now, let's also make an error in CDL, because here we should see this trigger in the Siona hook. So 9 errors in Torch. Ah, this is the problem. Why don't I see it in Siona then? Okay, this is almost right. Oh, come on. So why doesn't this... Like, is it not... Does it not hit this function? No, it does hit this function. So if I put it here, x int equals 4. My Siona hook doesn't really work because it says passed. Why? Very close now, come on. Well, I can just run the command manually, I guess. So I can run, what does it say? This one. But it doesn't check anything. This is the problem. Search paths, src, no source files found. Okay, the final bug to fix. So finally, okay, the nuclear exclude works for now. The final issue is that shows no source files found. Actually, let me paste everything to Gemini. Okay, this is it. Finally, we can move on. Yeah, so it's searching a bunch of shit. But like, where is the... How do I copy this? Okay. So why no source files found? Happens because specific. If you have a file and exclude or ignore, but then explicitly the config... Jesus Christ, come on. Use a dedicated config. Since this file has conflicting dependencies and needs a different group, the cleanest way is to give Siona Hook its own mini config. Seriously? Create the file name Pyrite in your root. Okay, update your pre-config flag. Okay, I don't dislike this as much, Jesus Christ though, but still. So, we need a new file, Pyrite config Siona, which reads all this stuff. And then we just tell... We can write in this about the paper. So, about this in the paper. So then it's just -p now. I see. -p. And what is it called? Pyrite config.siona.json. Interesting. Okay. So now CDL, oh, please work now. It does work. Wow. Okay. Woo, finally. Okay, so this was pretty bad. Where is my... Oh, here it is. So this is the error I induced. Okay, all right. And we can actually finally run pre-commit now. Okay, so now we have to fix the errors. Finally. Okay. So these are actual errors, right? Oh, look, for example. Okay, so let me clean this up. So git status, git add PyProject UV lock. What did I change in models? MIMO models. Oh yeah, we deprecated. Well, actually, you know what? We did not need to deprecate accelerate then. I'm tempted to leave it back now. Let's leave it back, yes. Staged. PyProject, because it's a false flag, right? We don't want to do that. So I gotta put back PyProject and UV lock. Now, what the heck else did I change in PyProject though? So this is a trick where, let's see, UV lock. So let me put this back then. So I need to put diffusers back. And if I do put this back and I lock again, I should see no difference in the lock file. Right, so I can just restore this here, okay? And then I can do a lock. Okay, UV sync. I mean, this is still bad. It's like we're wasting a lot of space on this, but it's fine. And now if I do git status, why is my git lock changed still? Git diff UV lock. Oh shit, I updated accelerate. Oh, damn it, it did a bunch of changes. Here's the litmus test. Does my train still work? Because I really don't care if my train still works, as long as my train still works, right? So that should be fine. Where did I train? Here we go. MIMO train, save deers, models, check. Nice thing about Hydra is that we can actually change everything from the command line. I forgot to say, my bad, UV run. I have to put the group back now, group torch. It's not that easy. There we go. Okay, it seems everything still seems to work, so we're all good there. Training works as intended, good. All right, so we did a tiny update by accident, but it's fine. So git add PyProject UV lock, git add pre-commit. We need to add this new pyrite config file, I guess. And what else did we change? Oh, models. I don't want the changes in models, right? Yeah. Because these are all deletions of the thing, but I want to keep it. So git restore src MIMO models. Okay, so git commit -m, add strict rules for based pyrite pre-commit hooks. So now I can finally call. Okay, there's a bunch of stuff here. Now, of course, I'm gonna get a ton of errors, which I have to fix now. But this is the point. Okay, so did it change my thing here? Yes, it did. So git add pyrite config. So git commit, no verify. We're gonna bypass this. Okay, so now we only have one task left to do. Just pre-commit, run all files. We need to fix all the pre-commit errors, because now it's picking up some real 20 errors that we have to fix, which some of them are ignorable. So for example, MIMO data, line 17. Okay, so now we can finally get to clean coding. CDL model, it doesn't know what it's coming from, right? So a group data set type of type string. So then we can just force cast this to a string. And this should clear that error, because the code is telling us, hey, you did not force cast this to a string. There we go. Actually, this is a good question though. Wait a second. This is maybe a real error. So wait. Check this out, because there is a trickery here. So if I train with this, so now we're finally fixing. This is where typing is useful, because I think this is a real mistake here. These are not integers. I remember this from yesterday. Okay, so we'll finally fix a real mistake. So what's happening here is that if I look at config now, there we go. So config CDL model, shit. This is not a string at all, even though channel config wants a string here. So now that I see this, what the heck is this even? How do I get the string out of this? Because I have a data set. So is it just str of f CDL model? No. What? So how do I access values in HDF5 dataset? Well, numpy array, but this is not a numpy array. What the heck is this? How do I even load these things? Scalar. What? NumPy as array? So what did I store it as? How to load string from H5 file dataset. Oh, it's as type. Oh, it's as type. Is it? Definitely not. Shit, I should have put it like D type, H55 string D type. You can write the NumPy array with string D type to it. Dude, what is this junk? Like, I'm actually saving the wrong stuff now. So NumPy as array, fcdl model, D type T? No. D type str? Squeeze? 0? No. Okay, so I don't know how to, I'm making some big mistakes here because how to save and load scalar string from H5 file. So how do I load it back? Holy shit, as str? So fcdl model as str. Nope. Like, what is all this stuff? Oh my god. Bytes has no object attribute as str. This doesn't even work. As str. To save scalar integer. So how do I do it with a scalar integer? Data. Python integers and NumPy scalars directly. Damn, this is not good how I save these at all. So who saves these to disk? I save them on train, right? No, CDL does. Here we go. So I mean, this is fine. Create data set. So is this different for int then? What about numRx? Yeah, okay. So this I have to do like this. Wow, this is insane that these are scalars though. This is not a good format at all then. So this will force int casting, which will make it not complain. We have to fix the string casting though. So can I just take like str? Nope, I cannot take the str. Dot encode? Decode. Yeah. Okay, so I have to decode the string. And I have to force cast it to a... Well, I guess decode returns a string, actually. Okay, so now I got rid of 3 pre-commit errors. And I believe sampling has exactly the same errors. No, because he does... okay. Again, we can go back to pre-commit, run all files. Why, okay. So we only have... Well, now we have more errors. Yeah, we did worse now. Get item not defined on data type. Yeah, we did worse actually. Yeah, I mean, conceptually this is pretty bad code because we're saving a mysterious file to disk and we have no information on what types are in it. So there's an implicit convention here. Now, the cheap way is to just type ignore this. This should quiet some errors. I don't think these are... well, we have to ignore all the lines separately, actually. These are not fixable that easy because... actually, they're not fixable at all. Without the schema, we can't save arbitrary stuff to disk. Okay, so let's leave this for now. What other errors do we have? But at least we actually fixed this. This is why typing is still helpful. Okay, so now we have some errors and losses, and it complains about line 8. Oh, I see. This is wrongly annotated. So this is a tuple of tensors. Very good catch, right? It's not a single tensor. So it's a tuple of 2 tensors. So this is the correct annotation. Let's see how many errors did we fix now. Okay, we're making our way. 16 more left. We have an error in models. Line 8. Error. UNet 2D model is not exported from diffusers. This is diffuser's fault. This is not our fault, okay? So we can ignore the all import private usage. I know this trick here. Report, we can set this to false because there's some modules are bad. So diffuser's fault, it's diffuser's fault because they did not expose that in their API. Even though the import obviously works, because if I click it here, it takes me there. Okay, other errors. We're getting there. 15. Models line 20. Tuple of int. Oh wait, it wants a tuple of 4 ints? Like this, right? We need to tell it exactly what it is. Is it? Yes. Okay, 14 left. Models 55. So this is very informative now for a developer because they can only look at this and, oh, I have to pass exactly 4 ints. Yeah, so all the tuples need to be... I guess this can be int then too. We can, let's see if we nailed one. Anticipated. 14 errors left. No. That one does not yell because of missing. I'm confused though. Wait, does tuple of int not work generically? Huh? Wait. There's maybe some trickery here. So what's the problem here? It says type literal 16. Why is this literal 16? Hello? Why? Oh no, expected 1 but received 4. Nah. Okay, so it is the 1 but 4. Yeah, okay, so this he wants explicit. Oh, I see, because anytime it locks it down to this. Okay, this is kind of a fake error. Sometimes these type checkers are not, they're not the best. They're a bit too strict, but anyways, that's fine. 55. What does he want here? Forward. Aha, forward overrides in an incompatible manner. This is a big problem because when you override the method, you're supposed to respect it. So it's warning us that we did something bad here. So what is the forward of UNet? There we go. So we're not respecting the union contract on the output, which I believe is the only change. Yes. So it should be a union. Oh shit, but I need to actually return a union. Ugh, I need to form a UNet to the output. Okay, fine. So I'll form a UNet to the output with output equals output. I just need to import this though now. Where do I import this from? It's from the same file. UNet to the output. It is not from the same file. God damn it. It's from diffusers. I have to go all the way now. Dot models dot unets import. Do I have it here at least? I do not have it here. Dot unet 2d. Okay, here. And tuple is the more modern tuple. 14 errors. Let's see if this introduced more. Sometimes it does, in which case we may drop this. Yes, it did introduce a new error now because line 66. No overloads for get item. So we get a union. Argument of type literal sample can be some of the key of slice any. Let's see, does it want dot sample? I believe so. Okay, back to 14 errors. Cannot access attribute for class tuple. This is a big problem because if this is a tuple and 67 cannot attribute, cannot access shape for class float. I'm gonna have to annotate this as a tensor. Hang on, I'm trying to nail some of these as much as I can, but I'm gonna give up at some point because these are, honestly, these are all no parameter named output. Line 69, no, 66. Shape for class float. Yeah. So we can guard against these. So if not type time step is torch tensor raise value error. Now here's the nice thing about typing. You can do guards like these and then typing will figure it out that, hey, I actually specialize this, because the problem here is time step could be either a tensor or a float or an integer. When I write time step.shape here, it's not going to work on floats or integers. Okay, so wrapper method only supports tensor time steps. Now, because I wrote this error, typing is smart enough to read that. See, it fixed a ton of errors now. Because it's special. Now, what's the syntax here? So if not type time step. Oh, I see. So if time step is not. Okay, fine. So if not is instance time step torch tensor. There we go. So now we magically fixed 3 errors because we specialized time step. I can do the same by specializing sample. I can specialize the output. So if not is instance outputs. If I don't get the UNet to the output, raise value error, wrapper expects diffusers to return an object, not a tuple. So I've done one more specialization. So now this should not yell anymore. We're getting there. Line 75, same issue. Argument missing for parameter sample. Oh, I see. UNet to the output wants to call it sample. Okay, fine. So we nailed 2 more errors. We're getting close. There we go. Next, models line 92. Aha, so this is a NumPy thing. This is nice. No overloads for lin space. So what? Start, stop. So what does lin space expect? Start, stop, and what are start, stop? Array like. I'm not happy with this one. So what? If I say start, stop, and num should be an integer. Here's my problem. Good one. Big mistake. Number of noise levels is an integer, not a float. So this was yelling that, hey, you can't pass an integer to a float to lin space in the third argument. It is a bit hard to read these, but once you get a hang of it, they're really helpful, right? Now, again, this is all typing. This doesn't matter for Python. I can call this banana if I want to. But it helps you as a programmer. Okay, so this was a big one that we caught for clean coding. Okay, 5 more remaining. Line 99. UNet config. Sample size. Aha, this is the problem. Aha, so we also need to specialize this. So if not numRx, if numRx is none or numTx is none, we can also raise an error here. See, these are extremely helpful. So numRx and numTx must be specified for diffusers. That's because diffusers needs to know the sample size. So now we specialize these because we overloaded this get model to work with NCSN v2, which does not need them. Okay? Come on. How many? 5 more. Feels like we... Aha, this is the tuple int error. Very good. So we need to tell it wants 2. There we go. We saw this earlier, but it was masked by the other error. 4 more. We're done. Sampling now. Line 161. What does it want here? Aha, some omega conf. Okay, so I need to annotate this. I know what this is because an arbitrary config comes out, but that's not good. So now there's a trick here. Typing is pretty fragile with redeclaration. So I'm going to do the same trick here. I'm going to call this structured config. I'm going a bit faster, but it's fine. Let's see. Okay, 4 more errors. 161. Oh no, shit, we're back here. So error. Type dict key is not assignable to something config. This is exactly the same error as in... I think we have to ignore this. So type, I know this one. It's because omega conf cannot guarantee that... Okay, so in some rare cases like this, when you have like... This is still omega conf's fault. It's not our developer fault, but it's because they can't guarantee the output of this toObject function. It could be one of many things. It could also be none, unfortunately. And then you can't... I guess you could annotate this, but then it ruins your downstream annotation because we really need this. So if I don't put this here, this is fine, but I need my code to know it comes out like this because then all my other functions depend on it. So then the typing works, okay? So we're gonna ignore those two. We should be down to 2 errors now. In the torch branch, we have some Siona stuff. 2 more. MIMO sampling, 217. What does it want here? Aha, alpha 0. Oh, I see. Alpha 0 is a float or a string. Else, aha, I need to guard it here. So here's the trickery here. Alpha 0 can either be a string or a float, but if it's a string, it only has to be auto. So if is instance alpha 0 str and not alpha 0 auto, then we have a problem. Raise value error. If alpha 0 is a string, it must be auto. Let's see, is the checker smart enough to catch on this, or do we need to move this at runtime? It is not smart enough. We can leave this here, but unfortunately we have to duplicate code now. Okay, I'm gonna leave it here, but the problem is my type checker is not smart enough to infer it. It's a bit more complicated, but so it should be like this. If is instance CFG alpha 0 str and it's auto, else let's see if the type checker catches onto this. Now we're guaranteed that it should be a float, right? Nuh-uh. CFG.alpha 0. Where does the int come from? I'm sorry. Why does it tell me about int also? Then the easiest way is to say if not is instance float raise value error. If alpha 0 is not auto, it must be a float. This will tell the checker now that interesting. Let's see if this is enough to specialize it. Okay, finally, last one. Last error, sampling line 228. It's still an argument here. Aha, sample size tuple. Okay, the classic tuple one, because it wants tuple int. And we are done. Holy shit, we fixed all the typing. Okay, 7 more errors now on the CDL branch. Now to make my life easier, I'm gonna have to install the Siona group. So thanks to UV, I can just do UV sync group with Siona because I want to have the package locally. Did I not sync with Siona? Oh, interesting. I guess I did. Okay. So now I'm gonna run again, pre-commit run all, and all the errors are in CDL. And I have 7 errors to fix. Ah, I forgot. UV is gonna change my environment now. Okay, this is a bit slow, but it's not as bad as before. Okay, 7 errors, come on. Line 43. Now these are a bit nasty because Siona is a bad package and TensorFlow is bad and evil. Oh, I see. This is my bad. So you can't annotate. This is easy. This is an easy one. Because actually I learned this morning that to annotate NumPy, you're supposed to use this special NPT module, not NumPy array. So to inform a type checker, you're supposed to use npt.nd, what is it called? Yeah, nd array, and then it also takes as input the data type. Do I have MPT here? Yes, import NumPy typing. Oh, wait a second. Whoa, 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 whoa. Does NumPy typing not exist in this version of NumPy? Okay, good. We fixed 2 errors. Line 92. Right, so now actually this is a very powerful specialization because it also checks the data type before running anything, which is pretty wild. I mean, this is the whole point of Python typing, right? Line 92. Again, the classic CFG, which I cannot override, which is fine. Okay, so I'm gonna do the trick. I'll call this structured CFG. And I'm gonna CDL config this. And I'm also gonna ignore that error because I can't fix that one. There's probably a systematic way to ignore this, but it's fine. Maybe not because it's too broad of an error. Okay. So now we have some unbound things, which is also good because it's 4 more errors. There we go. So 186, 789. So what happens here is when you see an unbound thing, it means, hey, this may not exist yet. The reason is if num_chunks is 0, this loop doesn't get executed and these never exist. So this is very easy. So if num_chunks is 0, we can raise an error. And we should do this. Like, again, otherwise you would be stuck. Need to run generation code for at least 1 chunk. Otherwise, if you wouldn't have this, you would die debugging this because you would figure out like, oh my God, why don't I see these variables? Well, eventually you would figure out that this is 0, but then typing is not smart enough to recognize that ceiling. I guess it's always 1 because of the math guarantees here. All right. Okay. So let's see. Now the type checker now sees that num_chunks interesting. So the type checker is still not smart enough. The solution is to initialize these then. Gains, tau, h, frequency is none. The problem is if I do them none, the type checker will yell that they don't exist. So we can do this. This is how you solve this. So so clean code wants these to exist always, even if there's a chance this loop may not execute. Now, even though we added the guard here, which I'm kind of bothered by, right? Because you would think, wait a second. I'm so dumb. It's less than or equal to 0 because it could be negative. I think that's okay. Check this out. Did we nail it now? No, we didn't. It's still not smart enough. So I can't even guarantee that if this is at least 1, if I write it in reverse, if not greater or equal to 1, because this guarantees me if this is at least 1, range guarantees I execute at least once. Nuh-uh. No, type checking is... It's not perfect. It's a case where it's a bit dumb here. So I guess we'll leave it 0 because it makes more human sense. This should never be negative, right? Now what's gonna happen is I can initialize these, but still the type checking will say, what if these run, but the loop never runs? What's the problem? I cannot access .shape for none, okay? So then I'll say if config and gains and tau and h frequency. So if it's verbose and all of them are not none, this is shorthand for they're not none, all right? Then I can execute that piece of code. Okay, and we're done for good, okay? That's it. So we're done with type checking. So this was an exercise on how to write clean code. And this is really, really helpful, right? A bunch of runtime checks, not too much code overhead, but everybody's happy now. So we're actually done now. Okay, so git add py project, MIMO CDL, MIMO. Oh shit, I'm just gonna add everything, I guess, right? Yes. Yep, git commit, fix all type checking errors. We fixed as many as we could. Some of them, I mean, of course you can ignore everything. You can just add hundreds of ignores, but that's not how it's supposed to work, obviously. There we go. So we have the hooks. Now, if anybody wants to edit the code, they will have to make sure they obey the type checking, right? So any new piece of code, and that's it. We are done for good. Let me run a quick training to see that. So if we run a train quick and then a sampling quick, everything should be good. Okay, so now before we start writing the paper, there's one more thing I wanted to do. Yeah, okay. Which is a bit different. So let me merge this PR in the public thing. Because we're running out of time, I need to write the 4-page paper today too on this, and I'm gonna do it on stream. But so we can finally merge the giant ass Omega conf and whatever Pyrite PR. A lot of changes here, including a custom. Yeah, we should definitely write all this in the paper. Like, this was very valuable, what we learned now. Okay, so this is merged. So then I can check out main. I can pull it. Okay, one more thing I want to do. Data fidelity. I noticed something because I added this plot function. Okay, so I added this plot function to plot the distribution of the data we generated compared to the one that was in the original paper, and there is a difference there. Okay, so I would like to get those a bit closer, just a little bit, not too much. Let me move HDF5 storage to the main dependencies to simplify a bit, because I don't want to have too many dependency groups. Okay, so UV sync group torch. So then let me add this plots. Now, interesting, here's what's gonna happen. Now I can run pre-commit on this. UV run pre-commit, no, not, damn it, not, it's pre-commit. Run all files, okay. Let's see if it complains. Okay, so I formatted it. Okay, it passed the Pyrite check, very good. I believe it has one error because there's an unused SNR here, which I believe should be SNR times this if we want to be correct. Let's see, is it gonna reformat it? I think it will. Yes, it will. Okay, there's a big ass formula. Now the point is, though, my whole idea is if I just run I just want this to be so UV run group torch. Actually, no, this doesn't even need torch. It's just UV run. It does need torch because I need a numpy. UV run group torch plots. I want this to be the plot script for the paper too, and this should not live in SRC. That's all fine. Except for one teeny tiny problem. The distributions don't match. There we go. So now this automatically, I wrote this off stream, but it's fine. So what this does is, the blue curve is the data we used in the paper. The yellow curve is the one we just reproduced with Siona. My question is now, do I have time in like 30 minutes to make these a bit closer? I realize this is very hard to do because the paper was using MATLAB and this one is using Siona, which is like fucking insane. Like, I don't even have MATLAB. So I have to blind guess a bunch of stuff. Is it worth the effort, or do we just write this concern in the paper and we just... Now, the reason why this matters is that because the generative model from the paper will follow the blue curve, the reproduced one will follow the yellow curve. That still means we got training right, except the data, because this is a pretty complicated paper to reproduce, right? We had to reproduce data generation too. Let's give it a shot. I think I can make these a bit closer, maybe just a teeny tiny bit. One idea, so the way we're gonna do it, now, I'm gonna have to switch to Siona, okay? So I'll sync with group Siona, okay? Again, because we also have a bunch of incompatibility shit. Now here's what I want to do. So in the verbose, plot generated data compared to reference data. Let me just, I'm gonna do a cheap shot here. I'll copy the code a bit. Can I? So if I do UV run Python, can I import, what is it? From plots, import capacity. This works. So I can actually import these functions in CDL directly from the root level. Okay, so from plots, import capacity, get CDF. Okay. And then I don't have to copy that much code, actually. This is not too bad. And maybe I can modularize this. Right? I can get, let's see. Yeah, so I can do plot CDFs, okay? So what I'll do is, I'll take ref path. Let me just modularize all of this so that we don't copy code, so that we actually use this. And I'll take repro path, because this will always be a plot of two things. Let me show you, let's do a smarter thing. Paths, path. Should I take a list of paths? And then a list of plot labels, and then I just compute the capacity and plot for everything, okay? So then I'll say like this, if not length paths is length labels, arrays value error, list of files and plot labels must be synchronized. Okay, so the users know what to use this. And then I'll just do for path label in zip paths labels. And I guess I'll take an I too. Nah, it's too heterogeneous. Fuck me, because one time I need to load with HDF5. This is so annoying. One time I need to load with H5Py. What, should I add a flag on how to load? And the convention is what? H5, HDF5 has the key output H, and this other guy has the key data. So then I need a flag too. Uses HDF5, a list of booleans, and I should check for triple equality then. I need the list to be synchronized. Uses HDF5, and then this will be use HDF5 to zip in uses. I don't think this is the best thing to do, to be honest. Kind of fucking annoying. So then I do if use HDF5 contents is, I gotta do HDF5 storage load mat, because this is what the from path, okay? And let me do channels and capacities. Okay, so list. I also need to normalize this. And I have to do this special thing. Okay, so this is not that bad. So channel. So this is a hard-coded line. The reason why I do it like this is because in the paper I want to plot 4 things at once, ideally. What the model generates, what both models generate, and their training data. So then I have to cut the first subcarrier from this, because that's how we did it in the paper. This I can homogenize with my code. I also need to normalize. And I need to compute the capacity. Okay. So I can say channel, channel, and capacity. And I think I'm done here. Else, we go on the other branch. I got a load width. Possibly we'll have to normalize here too if I try to homogenize it in the next half hour. So with the path opened as R, I load from this is good, so this becomes channel and capacity. Okay, so now I'm guaranteed to exit with channel and capacity in both cases. Now the CDF is easy, right? Because I do x, y equals get CDF of the capacity. Let me set up my plot then. Okay, so a single figure for everything. Plot. Okay, we're getting there. Actually, I don't even need to store these then. Perfect. So then I do x plot. I just plot them immediately. X and Y. Label will be label, because I want to write whatever I want. Line with 2.5. And once I'm done, that's it. So now I have 4 plots. And I set the title and everything on the outside. These are universal. Yes, yes, yes. Good. Pretty good, not too bad. So now what I can do is I can leave the main as is. I don't need to bother this, but in my CDL, I can now just import one thing, plot CDFs. Okay, and I don't give a shit about how it looks like. So there we go. So if CFG verbose, I'm gonna cut this plot. I don't like it. Let me replace it with this one. And you know what? I don't like this shit either. So this is gonna save us a lot of functions. Yeah, forget about it, right? Oh yeah, it's gonna save us a ton of stuff. I don't even need to type numpy anymore. I don't even need matplotlib here technically. Okay, so if I'm verbose and href is not none, where is the data set? So my point here is that I want to plot exactly the data I generate. So what do I need to plot? CDFs. Okay, so reference train path. This I'm gonna have to hard code. I don't know how to get it, generally speaking. Well, actually I do. It's just Hydra and an argument. But for now, let's, here it is. I'm gonna have to get this because I'm too lazy, okay? So this is always the reference path. The generated path. So this is ref path, and repro path is actually cfg.savepath because I just saved it to file, which is perfect. So then I just plot, and what labels do I want? I'll just do it right here. So I'll just plot the CDFs of my ref path, repro path. Labels will be, what did I call them in the plot? 2 strings. And uses HDF5 will be true, false. All right, and what did I call the labels? CDF, I called them original reproduced. Very good. Original reproduced. So now, if I go and I run, I need to run this app now. So now I'm gonna do, let me run pre-commit first. Run all files. What I need to do now, any typing errors? I did a bit of reformatting, it looks pretty clean. My main concern now is oh, it's not a list of paths. I misannotated it. Oh, here we go. List of strings. Very good. Typing helped me. Very good. And this returns a none. I forgot to put that, right? None. Yeah. Doesn't return anything. Good. So now, how do I run this? Well, I run uv run group Siona -m mimo cdl. Let me save these to a new file. Okay, so what configs do I have here for Hydra? I just need a save path. Oh, is that all I need? Oh, and the channel. I guess the channel is C by default. Okay, so then I say save path is, and what is save path? Is it the full directory? Yes. Data, paper, C.h5, okay? No, I forgot to override because there's too many channels. Where's the number of samples? Oh no, 1000 is good actually. Now the trick is I want to see the plot and it's not gonna work, but now I can just switch things here in this script and I automated the full plot. Takes about 1 minute, which is kind of bad. It's a bit long, but it's fine. Yeah, this is gonna be a YOLO because the only thing I can think of is I'm gonna change this V to an H. That's one thing I can think of. I'll change this FFT size to some other number, which I'll magically try to guess. Same for this one. That's all I can think of. And maybe this randomization, I'll take 0 like they do. Can't think of other stuff though. This value matches the paper, this value matches the paper, but it's not enough. Maybe I can set the speed here for Doppler to match, but it's very hard because I have to match some random ass library NVIDIA wrote. Oh, there we go. The plot is in. Is this the plot? fucking hope so. Or is it in like... It's not in some weird Hydra location, right? Oh, come on. Okay, you should always delete files. I'm gonna have to run this again. So, yeah, so I'll have to guesstimate this. We'll take a quick break. Thanks for sticking around. Let me take a quick break while this is done. All right, we're back. This is not great because that was not the plot, was it? Oh no. So, where is the plot taking place? Plot CDFs? Am I blind? CDF results. Is there a refresh? Ay, 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 ay. This is not the plot. Save fig. I think Hydra is messing with my run directory. But it should write it here then. It's not here either. I don't know what else to do then. I have to put a breakpoint here. And I can make this faster if I just say... Am I blind? No, I'm not blind. CDL, what was it called? CDF something. CDF paper. So I can do a trickery here. I can set the max chunk product to 50,000. Thank God we did Hydra, because I can easily change that. This should make it a bit faster. I'm curious to see where is my directory though, because it seems to save into some magic unknown location. Oh, come on, dude. I need this. We can't waste time on this thing. So plot CDFs. Huh. There's no error, so it should definitely save somewhere. CDF underscore results. Samples, final, data paper, CH5. Oh my God, I didn't set verbose to true. Eek. Obviously, so verbose is true. Thank God for Hydra. Okay, this should nail it now. Because we weren't actually plotting. I mean, it should, unless, of course, there's errors in the function, which we never saw. Which may happen, but it's fine. I know how to speed this up. If there are errors, we'll run it with smaller data quantities, so we just see the plot. Come on. I just want to get there, because then I want to change a few things here, and that's it. I don't know what else to do anyways. Okay, no crash, so it's loading the big data first, which looks okay. That looks promising. Capacity. I made a mistake because I named my variable exactly like the function, which is the dumbest thing ever, right? So local capacity. Okay, again. So now let me cut the data because this is taking too long. So we can say something like num samples is 300. This should be 3 times faster. Yeah, it should take like 10 seconds or something. And I still have a breakpoint here, which is annoying, but it's fine. Okay, and if I see, okay, it's here. And it reproduces, good, perfect. So I have everything automated now. Good. Pre-commit, run all. So now what we have to do is we just have to guess some parameters and YOLO it. And 300 channels is kind of enough to give me the rough curve. Well, HH. Let's see if this is closer. Come on. So switch the polarization to horizontal instead of vertical. I have no idea what this is gonna do. But there's an angle which should be 45 degrees if I'm not mistaken. Single dual VH, for single must be VRH. Carrier frequency, vertical spacing, 0.5 is set to none. Horizontal spacing, 0.5 is set to none. Precision, single double is set to none. Okay, let's see, is it closer? It's not closer, it's about the same. Wait, one mistake I made. We need a fixed x-axis there because we can't see shit if the axis keeps changing. So set x lim from 30 to 60. Again, I'm just guesstimating it. So are they really that far apart or it's an optical illusion? So now the other way to do is I need to look at my old MATLAB code and try to guess what the heck was happening there without actually being capable of running. So I know I fixed yesterday, it's NT111. So it's single polarization, a single row of antennas, right? There we go. A single column event. Maybe if I flip these then. Okay, we can try placing the array in reverse. Okay, so I got the x-axis wrong. It's not 30, it's like, sorry. It should be like 45. We're getting there, don't worry. 45, 75. Seems more appropriate. What else can I do? So I can try flipping the array around. So it's one row and the other number of columns. The spacing is half. This I know for sure. Spacing array is half, yes. Delay spread and these two guys I got. Doppler shift, it's related to speed here. I'm just gonna have to YOLO guess this, I guess. Okay, so these are still not... So the gap is about what? Like 3 whatever unit this is, bit per channel use or bit per second per channel use. Okay, all right. Let me try flipping these around then. So if I put 1, 1, I mean, this has significant consequences, so I'm not gonna do it. It's gonna change the shape of the data. No. Carrier frequency is right. If I put this to 1200, am I gonna nuke everything? I need to see the raw H frequency. Oh, num-effective subcarriers. Fuck me, it wants to be a multiple of num-tx. Ay, 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 ay. So what is this? Oh no, this should be 2048, right? Yeah, this is 2048. Maybe I'm getting closer. Maybe. So how is this not? Oh, dude, I don't know how to change these. That's the problem. Oh, I see. It's because of these stupid guard carriers, right? So resource grid. Let me just do 0, 0 then. And 2048. Is this gonna work? Nope. Yeah, there's no way I can do this, right? Like, I'm basically left in the dark here. I mean, I don't need all these patterns, to be honest. None. Right, so we can ditch. Let's leave the prefix. So let me try it this way, actually. Let's see what happens without this. Nah, but I'm pretty sure the simulation was full in MATLAB. Okay, good. So what is H frequency now? It's gonna be a gigantic array. It is not a gigantic array. Because I forgot to put the FFT to 2048. Damn it. Let's try this one now. Now it should be 2048 shaped. Oh yeah, and the simulation is gonna take a crap ton more time now because it's doing why. Yeah, my computer almost died too. So I gotta reduce my max chunk product. I don't think this is worth it then. Okay, so what is H frequency? Okay, so now it's a big thing. So 9 samples, 1664 matrix, 14 time symbols, 2048 subcarriers. If I just take the first one, 0, all, 0, 0. Because this is what I do here, right? I take, but it's even more complicated because I take selected subcarriers and the gap. 10. So I take 10 every 24. But then my data loader doesn't give a shit because I start from the first one. And I take the first one anyways. I remember this because if I look at how I pick the data for training, so channels, there we go. Use only first subcarrier of each symbol. So do I take all the time symbols then? I believe I do. Symbol range. So it's subcarrier range. Oh, do I do like a diagonal pattern here? Yes, I do. So I cut these diagonally. So it's definitely not random. So for each sample, but then in the loader, I'm just gonna take the first subcarrier here. Random times should not matter that much. Interesting. This is the best I can guess. Yeah, so now this is gonna take a crap ton of time to simulate because I'm doing the FFT of size 2048. Maybe this is what really matters though. We shall see. So then I'm like a 3. Okay, so let me save this. Rename. This is not reference, it's with H. I don't think I even have enough time to generate all this stuff until the paper deadline. I think this is the last thing I'll do. Yeah. We'll do it this way. We'll randomize everything. So this should not matter. Maybe I think this may matter though, like the 2014. So maybe I can leave it running while I go shopping. Cyclic prefix length. I forget what this is in NR, but yeah. Because it's the other thing is we can look at the NRCDL channel. It has a cyclic prefix here, probably. Nah, it's too complicated because I have to find the simulation. It's tied to like the NR perfect timing estimate. Like it's tied to perfect NR perfect channel estimate. Which, what the heck is this even? Like, how do I know what the cyclic prefix, CPL, cyclic prefix length. Do I say this? I don't even say this. So what is it then? CPL. Sampling rate. It's too hard. I don't know how we can guess this. It's impossible with it. Without MATLAB, it's impossible. And I think it's time we let it go. Yeah, because we're running out of time, so we gotta do other stuff too. Maybe just one more minute for this. Yeah, this is actually it's worth spending more time to sort of talking about this in the paper instead of trying to kill ourselves to reproduce it. Now that said, if this thing makes it closer, that would be really nice, but I really doubt it though. I doubt it. This FFT size is killer here. And I don't even know the polarization. There's a speed tool. There's the direction. Maybe the direction is what? Uplink? Downlink? How do I know? Is it downlink or uplink? Like, what am I even doing here? Okay, let's see what happened. It's not significantly closer. So the subcarrier thing doesn't matter at all. Okay, so we can revert this. Yeah, the guards don't matter at all, probably. Taking random frequencies doesn't. Yeah, taking this doesn't matter. Maybe let me try. Okay, so this we can call large FFT. Maybe I can try running it again now with the small FFT, but without all those extra parameters, and that should also not matter. And also, I guess with oh, I didn't even bother putting random frequencies. Yeah, so random frequencies should also not matter, which is fine again. Yeah, it's like, can't even tell. There's no... Nope. No difference at all, which is pretty impressive actually. Okay, so random frequencies don't matter. This doesn't matter. Blah, 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 blah. This doesn't matter. What else are we missing to make it closer? Let me try an uplink here. Maybe. Oh, shit. If I try an uplink, I have to switch everything, which maybe this could be it. There may be a notable difference here. So let me try an uplink, but also by switching the antenna sizes, because it doesn't work. The shapes don't work out otherwise. Oh no, the shapes don't work out anyways. Why? So then let me put it this way and transpose this. Because I can say if the direction is uplink, I need to flip the last true axis. hrec.shape. Yeah, so I can do h frequency is, I can just do a conjugate tool, it doesn't matter. H frequency, and axis should be 0, 2, 1, 3, 4. Okay, let's see. So I'm flipping the channel. This should be a benign change. Nope. Definitely not this. All right, good. So at least we learned something, all right? So downlink is the answer for sure. I'm curious if I flip the arrays around, does this work now? Somehow it does. Okay, all right. Wait. Maybe if I flip the antenna arrays around. So we definitely know it's a downlink channel. It's maybe worth writing in the paper that we discovered something. But if I flip the... So the flippage of the antennas is the evil here. Wait. If I put the polarization back to V, wait. So maybe it's not an uplink issue. Okay, so this antenna is busted for good, this type of array. So I gotta flip the array back for sure. And this should give it back to me. Actually, I have no other changes so far. But I'm curious. Well, actually, let's check that. Oh my god, I hope I didn't ruin it or something. Let's check that it does give it back to me. But now I'm curious if I put uplink there. And I also flipped the channel. I wonder if... But without flipping the arrays, because yeah, flipping the arrays is really bad apparently. Like having your antennas, I don't know what this is, but it's definitely closer. Yeah, it does give it back to me. Okay, so now if I go uplink here, but with the same array, this should crash, and then I can flip the channel again. So if direction is uplink, all right, I can say H frequency is numpy conjugate, numpy transpose. H frequency axis will be 0, 2, 1, 3, 4. All right, last try. We didn't really do much. But I'm curious if this direction, it should not matter though if I understand wireless comms correctly, which is probably the overstatement of the year. Maybe, user terminal speed. Let me try some speed next. Nah, nothing notable. So this can be left as downlink. I mean, sure, we can leave the other one. If I try to add a tiny speed here, like 5 meters per second, does that bring me closer? Nope. On the contrary, if I try like, I mean, this shouldn't matter at all, right? Yeah. If I try a larger subcarrier spacing, maybe this, because it's kind of like millimeter wave-ish thing. Nope, nothing. If I try a shorter cyclic prefix length. Nah, it's impossible to guess this without delay spread is by far the most important one, and we know we have this the same and the carrier frequency, but apparently that's nowhere near enough, unfortunately. Oh. There's definitely a difference here now. 6 out of 76. I don't know, like what if I do 76 times 16 and cyclic prefix times 16? Let me see. Ah, no, because I'm gonna slow my computer down. Damn it. Yeah, no, I don't like this. If I do it times 2, then does it do anything? If I don't do a cyclic prefix length, does it do anything? Maybe. Well, I just did it, yeah. Yeah. Nope, nothing material. Okay, so we can leave this as is then. It's fine for now. Let's use the official demo, I guess. Yeah, we can leave a speed too. All right, I think this is it. We're wrapping up everything. And it's time to go to write the paper and do like 1 or 2 figures. One of them will be the training curve. The other will be the distribution of generated data, well, 4 plots, and that's it. And the third figure will be a block diagram of the whole work. Okay, so that is it. So git add plots, PyProject UV lock, src MIMO cdl, cleanup, plotting, and failed attempts. So we're done. We added clean coding everything. Let's take this and we can actually just merge it straight on main. All right, so we just merged this bad boy on main, so we can do git checkout, main, and we are done. Okay, so this officially sort of finishes the code. Let me run some sampling with the model we just trained, so we have one of the data. Now this is easy, of course, right? Because that's the whole point. So UV run group torch -m MIMO sampling. Let's see, where is the model path? We just trained the model for the paper, so we'll say model path equals models minus paper, and we'll take the last weights. Okay, so we will take weight step 120 4,800, which is exactly how many steps the model in the paper was trained for. And we shall say data path sorry. Now when I plot this, do I plot 4 or what the heck do I do here? Oh yeah, we should just plot up to 4, right? Yeah. Okay, so that's another fix. We only want to plot 4 samples. We're not going to kill ourselves plotting a bunch of stuff. So what do we do? Drop last. Okay, so I guess we need to tell it where the validation data is, which is weird. And where was it? Data new, right? Yeah, data paper was a failed experiment. So we'll say data minus new val.h5. And we shall say save dir. And what does it do? Oh, and save them to disk. Okay. So we should also save the synthetic samples then. So with h5py.file, right, yes, we need to save these for sure. There we go. The convention will be data key. Data is gonna be synthetic samples, and save dir unconditional repro.h5, or actually it should be unconditional.h5. Do I have h5py in this thing? It should, yes. I hope so. Py project. Yeah, we have h5py here because we need it here. So save dir will be data minus new. Okay, so we'll just put it here. Train val. That'll be h5. This will also be h5 unconditional samples png. Okay, and we only need to save the data. Oops, almost made a mistake there, and that's it. And how many samples are we training for? Are we sampling? I guess let's see its work for 4 because it should load everything. So it's not which file must exist. Oh, I'm sorry, 165? Oh. What? Model file. Oh shit. Oh, sorry, it's CDLC. Oh, almost made a mistake here. All right, so CDL minus C. There we go. Yeah. Huh. What? Line 179 in sampling. So train config has no attribute arch. Oh, yeah, because I can only access it like this. So it's a dict. Gotta be careful here because I changed some conventions which ain't good. Need to get this working. CFG train. Oh my god, there's so many of them now. Damn it. Yeah, we should really not do this. I guess. I wonder if I can trick it though. If can I force cast it back to a train config? I believe I can, yes. So maybe there's a cheaper trick here. So yes, this is a dict. And we shall say config train is train config config train. Let's see. Sorry. Dot arch. We can leave this. Come on. I think this should trick it here. Yeah, it does trick it. Okay. I just gotta see that the plot works. Oh my god, I haven't tested this in a long time. That would be really hilarious if it doesn't work. Yeah, so synthetic samples is dot cpu dot numpy. Come on. But is the plot good at least? Save dir. Yeah, the plot is good. Okay, so at least we got this thing going. And this is pretty much it. So we have 2 data. We have the old, we have 3. We just need 1 more plot for the paper, which is we're gonna have to regenerate some synthetic data with the old model, but the curves should match up in pairs, right? And that should be it for good now. And that's it. Then we're done with the, then we have the training log. So we need a plot of that. And then we can actually finally write the paper, which should take about 4 or 5 hours. It seems doable. Tough, but doable. A lot of work left. But that's why it's the weekend, right? That's what you would think. All right. Good. So data new now contains synthetic and saved. Okay. So now we can actually do a plot paired, not the plot paired, but the same plot function we can use from CDL, like plot CDFs. Very good. We'll just need all the paths and we'll plot the CDFs. And we have 3 plots. We just need the 4th one. We need the unconditional score. We'll take a break. I'll stop the stream for 1-2 hours, 3, and then we'll be back in full force, right? Gotta finish everything. Thanks for watching. Thanks for sticking around. I'll see you later today or in the next episode if you're on YouTube. Thank you. Don't forget to like, follow, subscribe, everything. You know it. Bye.